All right, class. Welcome to this practice problem set video. So we're going to talk about 7.4, the Pearson practice problems. So just in case you needed a little help on some of the problems, there will be a couple things that I want to point out as far as the quiz is concerned as well, because some of the questions here will not appear on the quiz. Um, let's go ahead and get started. So for the first problem, it says find the period of the function and use the language transformations to describe how the graph of the function is related to the graph of y equals cosine x. So the function that we have here is y equals 5 cosine of 2x. So remember that the generic form of sine or cosine is a, and I'll go ahead and use cosine here instead, of b times x minus c plus d. Okay, so this is the most complicated that it can get. So notice that the 5 relates to the a here, the b relates to the 2 here, and here there is no c, here there is no d. So those are equal to 0 in this case. All right, so if I wanted to find the period, the formula for the period is, remember, the period is given by the capital T, and the formula for that is 2 pi divided by b. Now we said that the b term is 2. So we have 2 pi divided by 2 is pi. All right, so that's my period for my function given here. So I'm going to type in pi and it'll give me pi right away. Then I'm going to check my answer. All right, and that's correct. So now what we want to do is pick the right choice here. How is the graph related to cosine x? So they're going to talk transformations here. So let's go ahead and quickly review what the amplitude of this function is going to be. Okay, so and how this function is going to look like. Remember that there are two different functions that I want you to know, that I want you to recognize. Okay, the first one is the graph of sine. The graph of sine, if you recall from the video, it starts at 0 at the origin, and then it goes all the way to 2 pi, right? So it goes, and then so it goes all the way up, then down, and then all the way to 2 pi. So the amplitude of the sine is 1, and it goes from 1 to -1. All right, so the amplitude is 1. That's this height right here, right? The height is 1. And the period is 2 pi. All right, and so we have the amplitude, we have period, and that's basically what you need to know. So the graph of the sine looks like a snake-like graph, right? So it starts here at the origin and does this snake fashion. All right, now the graph of the cosine, so if you look at the graph of the cosine, it doesn't start here. It actually starts up here at the 1 instead of at the origin. So it starts up here, and then it still ends at 2 pi, but this time it goes down and up. So notice that it looks like a U shape instead of a snake-like shape. All right, so that's the difference between those two graphs. This one still has an amplitude of 1, right? And it still has a period of 2 pi. Okay, now if I extend this graph, I can extend it to do one more period so that it goes to 4 pi. In that case, I just repeat. Okay, and then so on and so forth. So that would be an example of 2 cycles of the graph. Okay, so this is another set of 2 pi. All right, so that's how that looks like. So now, normally the cosine has an amplitude of 1, but if I have a number here like 5, that's going to make it go stretch. That's going to make it stretch, and that's going to make this go up to the 5 mark instead. So if this were 5 and -5, then in that case, it's just going to make it more stretched. Okay? So just going to stretch the graph. That's all the 5 is going to do. So notice that the 5 is a vertical stretch. So this term right here is for a vertical stretch. If that number is bigger than 1, then guess what? You have a vertical stretch. If that number is smaller than 1, then you have a vertical shrink or a vertical compression. Now this number here, on the other hand, doesn't do a vertical stretch, but it does a horizontal, okay? So this actually does a horizontal shrink. Okay, so basically this number right here tells you how many waves essentially you have, or how many wave cycles you have within one period. That's basically what this is telling you right here. So this is saying that I have one wave from 0 to 2 pi. That's what, two waves, I'm sorry, two waves from 0 to 2 pi. So this is sometimes called the wave number, okay? So basically, if that number is big, that means it's a horizontal shrink. And then if that number is smaller than 1, it's a horizontal stretch. So that's all you need to know about that. So what that 2 does, what does it do? What that 2 does is, instead of having one graph from 0 to 2 pi, you're going to have two graphs. Okay, so in that case, you're going to have two waves. So 1, 2. Notice that's two waves right there. So that's what that number says. You have two cycles here, two waves for from 0 to 2 pi. Okay, so let's go ahead and answer the question. So it says, how is the graph of the function related to graph of cosine? So according to what we said here, it's going to be stretched by a factor of 5 vertically. And it's going to, and then what the 2 does is it makes it more frequent. So it basically stretches it, or I'm sorry, compresses it horizontally. Okay, so this is a compression. So we're going to say it's a horizontal shrink or compression by a factor of 1/2 because of the 2. Okay, so let's go back to the function here. So we said it's a horizontal shrink by 1/2, because if it shrinks, that means it's getting smaller. So 1/2 makes it smaller, right? It makes it half as small, or half as large. And then this one's going to be a stretch by a factor of 5. So it's going to be horizontal shrink by a factor of, let's see, where is it? So we can see if we can find it. Horizontal shrink by a factor of not 1/5. Okay, there it is. So part D is a horizontal shrink by 1/2 and a vertical stretch. Yep, by a factor. So that's going to be the answer choice that we want. Horizontal shrink. Hold on, this thing is acting up. And then a vertical stretch by a factor of 5. Okay, that's it. All right, let's go to the next question. Okay, so sketch the graph of y equals cosine. So now we know how the cosine looks like, right? So we have y equals cosine. So remember, it starts up here and kind of looks like that. And so it's at 0, you get a value of 1. At pi over 4, or at pi over 2 rather, you get a value of 0. At pi, you get a value of -1. And at 3 pi over 2, you get a value of 0. And then at 2 pi, you get a value of 1. This is straight from the unit circle, if you recall. So these values are straight from the unit circle. Okay, so if we look at the graph, it looks like it's this graph right here, D. All right, so we're going to choose that one. And again, you can go on Desmos to make the graph. So you can open up another tab and type in desmos.com. And then if you type in desmos.com, you can go to start graphing. And there's also an app for this, so you can download the Desmos app on your phone, I believe. And then you just type in cosine of x. And then there you go. There's your graph. Very simple. You can even graph the other one that we did last time, the one that we did previously. So 5 cosine of 2x. And notice that it actually stretches it by a factor of 5, which is exactly what I was trying to tell you. And so notice that the blue graph is more compressed, almost like a spring. If you think of a spring, it's more compressed. So if you think of like a normal spring, this is very compressed, right? And then this spring is not as compressed. So notice the blue graph is more compressed horizontally than the red one. And that's why we said it was horizontally shrunk. Okay, so just a little visual of how that looks like. All right, let's go back to the problem. So let's check the answer. All right, that's correct. So is this an odd function? So the next series of questions will not be on the quiz. So there's a lot of questions that they ask you in this particular problem. We'll go over them, of course, but it will not be on the quiz. So you don't have to worry about that, okay? So what will be on the quiz is using Desmos or a graphing calculator or technology to make the graph, then sketch the graph on a piece of paper, and then identifying the key features, amplitude, period, frequency, that kind of stuff. All right, that's what will be, that's essentially what you're going to be having to do on the next assignment, right, which will serve as sort of like a quiz grade. Okay. All right. So let's go ahead and continue this graph. So notice that we only have one period of this graph, right? If we were to continue this graph, then it would look like that, right? Now this graph, this cosine graph, notice that it is a reflection about the y-axis. If you have a graph that is a reflection about the y-axis, we call that an even function. Okay, so that's even, meaning it's a reflection about the y. If you were to look at the graph of sine, the graph of sine normally starts at the origin and then goes like that, right? So if you were to continue it, it would look something like that. Now, this is not a reflection about the y-axis. This is actually a reflection about the origin. So if you think about it, this is a reflection about the origin like that. So if you were to put the line y equals x, something like that, or maybe like this, then you notice that it's a reflection about either one of those lines on either side. So that's called being a reflection about the origin, and that is known as an odd function. Okay, so that's the difference between odd and even. All right, so this is not an even function because this is not an odd function, rather, it's an even function for cosine. Okay, so the answer is no. Again, they're going to ask us a bunch of questions, but we'll answer them, but it won't, you won't be asked this. Okay. So is the function decreasing from negative pi over 2 to 0? So where's the negative pi over 2? Well, negative pi over 2 is right here. This is negative pi over 2, which is at 0. So basically, it's asking you what's it doing from negative pi over 2 to 0, which is over here. So basically, if you look at it, it looks like the graph is increasing. Okay, so it's increasing from negative pi over 2 to 0. Therefore, we're going to say no for this question. The next problem is the range from negative 1 to 1. So if the range are the y values. So if you look at the graph, well, the smallest y value is negative 1, right? And the largest y value is 1. So yes, that is correct. The range is from negative 1 to 1. So yes. Is the y-intercept equal to 1? So the y-intercept is where it crosses the y-axis. So if you look at here, this is where it crosses the y-axis, and it is equal to 1. So yes, that is correct. All right, now are the zeros given by n pi? The zeros are where it crosses the x-axis. So that's these guys here. Oops, not there. Here in blue and here, okay? So are those zeros given by n pi, where n is any integer? Okay, well, let's see. So n pi. So let's say n is equal to 1. Then that means that this is going to be 1 pi, right? Is that where it crosses the x-axis? Well, if you look at the here, it doesn't cross the x-axis at pi. It actually crosses the x-axis at pi over 2. So this is not correct, right? So we're going to say no. This is not correct. Does the function obtain a relative maximum at x equals to 2 pi n? Okay, so let's go ahead and do that one real quick. So remember, the maximum is, and I'll do this in another color, I'll do it in purple. The maximum are these points, right? It's where it hits that peak. So that purple is your maximum. All right, so let's look at the maximum in the middle, or in the right. Does it have a maximum at x equals 2 pi n? Okay, so 2 pi n. So what if n is equal to 0? Well, if n is equal to 0, well, 2 pi times 0 is going to be 0. So does it have a maximum at x equals 0? And the answer is yes, it does have a maximum at x equals 0. So that checks out so far. So let's plug in n equals to 1. So if you plug that in, well, 2 pi times 1 is 2 pi. Does it have a maximum at 2 pi? And the answer is yes, it does have a maximum at 2 pi right here. Okay, so yes, it does have that maximum at x equals 2 pi. So this checks out. So therefore, we're going to say yes. All right, the question is complete. Again, I'm not going to ask you this on the assignment, for the quiz. I'm just going to ask you the other stuff. So let's move on past this question. Okay, determine the amplitude and the period of the function. So then graph one period of the function. So the amplitude is, so let's go ahead and write out the problem. So we have y equals -5 cosine, oops, of 1/2 x. Okay. So it's important to note that the amplitude, remember that the generic form is a cosine b x minus c plus d, right? Here there is no c. In this problem, there is no c and there is no d. There's only a b and an a. So this is a and that's b. So notice that the amplitude is never going to be negative. Okay, so the amplitude is never negative. Amplitude never negative. So keep that in mind. So when we do our amplitude is equal to a, but a is not going to include the negative. A is just going to be 5. So the amplitude is 5. Okay, not -5. All right, so here it's going to be 5. We're going to enter. Now let's do the period. Remember that the formula for the period is 2 pi over b. Now b is going to be 1/2. So we have 2 pi divided by 1/2. So how do we divide these two numbers together? Remember, use KCF. Keep, change, flip. So you're going to keep the 2 pi. You're going to change this division sign into a multiplication. And then you're going to flip the second number, the second fraction, the denominator. You're going to flip that, and that's going to make it 2 over 1. All right, there's an invisible 1 underneath the 2 pi, and then you can multiply straight across. So 2 pi times 2 is 4 pi, and then 1 times 1 is 1. So this is just going to be 4 pi. So that's my period, is 4 pi. So 4 pi, and then you can enter. All right, and then we're going to graph one period of this function. Again, you can do this on Desmos, but I'll show you how this looks like if you were to just do it by hand. But again, you can do this on using technology. Remember that the cosine graph normally starts up here and goes down, right? And it normally ends at 2 pi, from 0 to 2 pi for one cycle. So normally that's how it looks like. However, because of the 5, the amplitude, instead of the amplitude being 1 and -1, it's going to go all the way to the 5. So therefore, it's going to be all the way up to the 5 and all the way down to the -5. And also, so it's stretched by 5, but also the negative sign that you see here, so I'll go ahead and show you the negative sign. The negative sign that you see here is going to actually flip it. Okay, so instead of looking like a U shape, it'll actually look like an upside down U shape. So it'll look like something like this, okay? So it's an upside down U shape, and it's stretched. Now the 1/2, what the 1/2 does is it makes the period equal to 4 pi, right? So instead of this being 2 pi right here, this will have to be 4 pi. Okay, so it goes from 0 to 4 pi, all the way to 4 pi. So basically, if this were, if you were to actually graph this side by side, technically 4 pi is all the way over here, right? If you were to be more exact with it. And so since the period is now 4 pi, it's going to kind of end at 4 pi. So it's going to look something like that. So upside down U shape, very elongated all the way to 4 pi. So it's very like slow to like do the cycle. So I'll show you this on Desmo so you can kind of get an idea, because this is what you're going to be using. So again, that's the regular cosine right here. I'm gonna do the other function, -5 cosine of 1/2. I think it was 1/2. Let me go back. Yeah, 1/2 x. All right, so see what I was trying to say? So you can fit, normally you can fit, so this is the green is the red that I have on the right side here. So see how stretched out that is? It's stretched out horizontally. And it's flipped, it's an upside down U shape. So that's what I was trying to tell you. All right, so that's how it looks like. So let's go down to the problem. So it ends at 4 pi, it's very stretched, so it looks like it's A. All right, so we're going to enter. All right, and that's one period of the function. All right, look at the next problem. All right, so determine the number of cycles that the following sine function has from 0 to 2 pi. Find the amplitude and period of the function. Okay, so let's go ahead and write down the function. The function is y equals -6 sine 2 pi theta. Okay, it doesn't matter if that's theta or x, same thing. Okay, it's just a variable. So again, this looks like the form a sine of b x minus c plus d, where in this case we don't really have a c and we don't really have a d. So it's really just b times x. And this right here is like your b, this is like your x, and this is like your a. Okay, so the amplitude is equal to 6, not -6, +6. The amplitude can only be positive. And then the period is 2 pi over b, and b is 2 pi, right? If you look here over here. So 2 pi divided by 2 pi is 1. Okay, so that's my period. Okay, now if they wanted the number of cycles, very easy to do. All you have to do for the number of cycles is use the b. So the b, I didn't actually mention this in the notes, but the b actually represents the number of cycles from 0 to 2 pi. Okay, so the number of cycles from 0 to 2 pi, basically the number of waves, is given by b. Okay, so that's what b tells you. So in this case, the number of cycles is 2 pi because b is 2 pi. So it's very easy to figure out. If they're asking you for the number of cycles, you simply use your b term. All right, for the given sine function, the amplitude. So again, this is key. I'm not going to ask you this on the quiz necessarily, but it's still good to know that tells you the number of waves or cycles. So for the given function, we said the amplitude is 6. For the given sine function, the period is, we found the period, it was 1. Okay, so that's my period. All right, and that's it for the question. Very simple. So let's go to number 5. All right, it says use technology to graph 2/3 sine of 6x. What is the frequency and all that stuff? All right, so let's go ahead and use technology and graph that. So let's go to Desmos and then we'll just do 2/3. Oops, I put a 30 there. Sine of 6x. Okay, so there's my graph. I'm going to zoom in on that. All right, so look to see what the frequency is. The frequency of this is very high, right? It's very frequent, right? So like there's a lot of waves for a very small portion of the cycle. So therefore, it looks like it has a pretty high frequency when you compare it to the regular sine. You see that's the regular sine. That's not very frequent. Okay, so very high frequency, but a smaller amplitude. The amplitude of this is 2/3 because that's what my number is over here, right? So let's go ahead and so now that we have the function, let's go ahead and write down the actual function itself. Okay, so we have that. So the amplitude is 2/3. Now this tells you how many waves we have, so that means number of cycles from 0 to 2 pi. But this also helps us with our period, right? So our period is 2 pi divided by that number. And so this is a fraction. You can actually reduce this fraction, divide by 2, top and bottom, and you get pi over 3. All right, so that's my period. So that means the function repeats after every pi over 3. Pi over 3, pi is about 3, so 3 divided by 3 is 1. So this looks like it repeats at a little bit over 1. Okay, if you can see that, it kind of does this, and then after that, it starts to repeat again. So this makes sense. This is approximately 1 is what the period is. So this makes sense. And then the amplitude is smaller than 1. So let's go to the graph here. Smaller than 1. The period is pi over 3 as we mentioned, so it looks like it's going to be this one. Let's go ahead and enter. All right, the next question, the frequency. What's the frequency? The frequency is simply going to be 1 over the period. So you got to do 1 over the period. So it's 1 over pi over 3. So that's my period there. And then again, you're going to keep, change, flip, right? So keep the 1, change to multiplication, and then flip the pi over 3, so it becomes 3 over pi. And put this over 1, multiply straight across, which is going to just give you 3 over pi. So that's my frequency. So 3 over pi. There you go. All right, we're going to enter or just click check answer. All right, the rate of change. So we haven't done this one yet. So the rate of change is something that was in the video that you'll need to know how to do. Okay, so remember the formula for the average rate of change is f of b minus f of a over b minus a. Okay, so how do we calculate that? Well, they tell you that the interval is from 0 to pi over 3. So this is a and this is b. So basically a is 0, b is pi over 3. So basically what we're trying to do is to do the average rate of change, we do f of pi over 3 minus f of 0 divided by pi over 3 minus 0. And that's how you do it. But we know pi over 3 minus 0 is just going to be pi over 3. Okay, so how do I do f of pi over 3? So the way to do f of pi over 3 is I'm going to take my function, my original function, which, you know, my function here is the original problem that they gave us, 2/3 sine of 6x. That's my original problem. So I'm going to take my pi over 3 and I'm going to plug it in for x, and that will give me f of pi over 3. Okay, so let's do that right now. So f of pi over 3 equals 2/3 sine 6. Now I plug it in. So I'm going to plug in pi over 3. Okay, and then we just got to do the math. You could do that on the calculator, or you could just, you know, do it otherwise. It's fine. But 6 divided by 3 is 2, so this is going to be 2 pi. And from the unit circle, sine of 2 pi is 0. And then 0 times 2/3 is 0. So this is just going to be 0. Again, you could do that on the calculator. All right, so f of pi over 3 is 0. Now we got to do f of 0. How do we do f of 0? We're going to do the same thing. So we're going to plug in 0 into the function. So f of 0 equals 2/3 sine of 6 times 0. All right. So 6 times 0 is 0. So this is going to be 2/3 sine of 0. And sine of 0 is just going to be 0. And 0 times 2/3 is 0. So we got 0 minus 0 in the numerator. And what that means is 0 minus 0 is 0. 0 divided by anything is 0. So my average rate of change is simply 0. All right, that's how you do average rate of change. So let's go ahead and look at another problem. Okay, so we got the function. So it says they give you two functions, 8 cosine of pi over 6x and then cosine x. So how do the amplitudes compare? Well, we know that the amplitude of g of x is 8 because of that number, right? So the amplitude of g is 8. And the amplitude of cosine, there's an invisible 1 there in front of the cosine. So therefore, we're just going to say it's going to be 1. All right, so if the amplitude of f of x is 1, that means that the amplitude of g is 8 times bigger than the amplitude of f. Okay. How do the periods compare? Okay, well, let's look at the first one, 8 cosine of pi over 6x. So the period is 2 pi divided by this number. Remember, keep, flip, change. So keep the 2 pi, change to multiplication, flip the denominator. So it becomes 6 over pi. Change this to over 1, multiply straight across. Notice that the pi's cancel, and then 2 times 6 is 12. So you can do that on the calculator and you're going to get 12. So my period is 12. Now if I compare that to the period of the regular cosine, Well, we know that the amplitude is an invisible one. The b is an invisible one. That's my b. So the period is 2 pi over b, which is 1, is 2 pi. All right. So on the one hand, I got a period of 12 for the first function, and then I get a period of 2 pi for the second one. So the period of g of x is 12. Now, how many times bigger is that than 2 pi? Well, how do we do that? Well, we just take 12 divided by 2 pi, and that tells us how much bigger it is. So like if this were 2, right? How much bigger is 12 than 2? Well, you simply got to do 12 divided by 2, which is 6. So you'll just say it's 6 times greater. In the same way, if the period is 2 pi, well, you're still going to do 12 divided by 2 pi, and that'll tell you how much bigger it is. 12 divided by 2 is 6. So we get 6 over pi. Again, the only thing I'm going to ask you to do is find the period, amplitude, midline, that kind of stuff. So I'm not going to ask you like these other questions like how many times bigger is it or anything like that, okay? And you got to know how to graph it using technology. And find the frequency. So it says, what's the frequency? So frequency is simply 1 over t. So it's 1 over 12. So that's the frequency. Sometimes the textbook gets a little bit, goes a little bit too deeply into things, as far as, these details. And then what's the frequency of the other function? It's just going to be 1 over that. So 1 over 2 pi. So how much bigger is it? Well, you're going to take 1 over 12 divided by 1 over 2 pi. Okay, so you take those and divide them. How do you divide them? KCF. Keep, change, flip. All right, so multiply straight across. So we got 2 pi over 12. This reduces to 1 over 6, so it becomes pi over 6. So it's pi over 6 times the frequency. Oops, I forgot the other one. Let me double check the first one real quick. Frequency is the reciprocal of the period. Okay, let me see. Let me double check that real quick. So the frequency of G is that. Okay. Okay, so for the previous question, it marked you all wrong if you put pi over 6 as the answer for that last one, but don't worry about it. That's actually correct. The book actually writes it as 6 over pi, but it should be pi over 6, so they flipped it. Okay, so I wouldn't worry too much about that. Like I said, I'm not going to ask you those kind of questions. Okay, so let's finish up we're right now in the, towards the end. The only other thing that I want to show you how to do, I want to show you how to do the midlines, okay? So again, let's go ahead and do the midline. Okay, so remember that the generic function is a cosine b x minus c plus d. So clearly that's a, that's b. There is no c and there is no d, but that means that the d is actually going to be 0. So this is actually an invisible 0 here. So this means that d is 0. Now remember that the midline actually, the d actually tells you the midline. So the midline for this is y equal to d, which is 0. Okay, so that's the midline. The midline is y equals 0. Now, so the midline of g is y equals 0. And then the original cosine, if you look at the original cosine, that also does not have a midline. That also has a midline of 0 because there's an invisible plus 0 here, and that's your d. Okay, so that also has a midline of 0, so it's not shifted at all. Okay, so midline, okay, so we would say the midlines are the same, which is y equals 0. Okay, that's really what I wanted you to know for that question. Midlines are really easy to actually solve. Okay. Recall that the graph, okay, so let's look at this. So sketch a graph of y equals 4 sine of x. So 4 sine of x, you could do that on Desmos, but remember that the sine function looks like this, and then it's stretched by 4, right? So 4 here, 4 there. So pretty easy to do, and is a period of 2 pi. So it looks like that one. Let's go ahead and enter that real quick. Now, by reflecting the graph, so now we want to sketch negative x. So if there's a negative inside there, it's going to reflect it about the y-axis. Okay, so that means instead of the function looking like that, it's going to reflect it about the y-axis. So if we do that, if we reflect about the y-axis, then that means it'll look kind of like that, the red part. So if I reflect it about the y-axis, okay, so it'll look like that. Okay, so it's kind of like that. Let me look at the other ones just in case. Yeah, so it looks like it's A. So we'll enter there. Now, if we reflect it, if we have a negative in front, then in front of the 4, then that means it's going to. So if you have a negative here, it's going to reflect about the x-axis. So I'm going to do the x-axis in red here. So it's going to reflect it about that. So that means it's going to look pretty similar, actually. In fact, it may look identical. Yeah, it'll look actually identical because, it still looks pretty identical to me. All right, so we're going to pick that function. It's going to be like that. All right, and then how do the graphs compare? Their graphs are the same. And that's it. All right. Okay, guys, so that's it for the Pearson practice. Again, what you need to know is how to find the frequency, period, amplitude, and you'll have to know how to do the graph and then the midline. If you know how to do those things, you should be fine as far as the next assignment and so on. Okay, for this lesson. All right, guys, that's it. I know this was longer than usual, but I wanted to make sure that you you had the help you needed if you needed it. Okay. Thank you guys and have a great day.